Hi, I'm Stu from Hive Mind Automation and welcome back to the Hive. In this gadget review video, I'll be taking a look at this Deta Smart LED downlight with Grid Connect. You've seen me look at smart downlights before, but this time I'll be installing custom firmware onto the downlight to remove it from the OTA cloud. So let's get started. In a previous video, I unboxed and reviewed the Arlec Grid Connect Smart Downlights, and I've installed 4 of them here in my dining room. This time I've got a Deta Grid Connect Smart LED Downlights, and these ones allegedly can be flashed over the air with Tasmota. If I'm happy with the results, I'll be heading to Bunnings to go get 2 more of these to replace the lights in the kitchen. At $32, these are a little bit more expensive than the Arlec units, but they're also a 10-watt unit, so they're brighter. And if we're successful in flashing them, I think the extra couple of bucks might be worthwhile. There's plenty of other Grid Connect accessories available from Bunnings as well, both from Deta and Arlec. So I'll definitely be testing more Grid Connect accessories in the future, and most likely flashing them all with custom firmware. So before we hack it, let's take a look at the unit itself. As we take it out of the box, we've got the light itself and this control box, and of course it's powered using the standard GPO in the ceiling cavity like the Arlec units, and that should be pretty standard on any downlights installed in about the last 10 years or so. Also in the box we have a quick start guide and we've got a rubber gasket, presumably for sealing in wet areas. We've got a warranty card, but we'll be voiding that warranty. We've got installation instructions and a cutting template. So first impressions of the unit. The unit itself is physically a fair bit larger than the Arlec unit, presumably because it's a 10-watt unit rather than the 9-watt that the Arlec unit is. But this control box is also smaller, so there's something going on there. The build quality feels good, and it appears to be made of a powder-coated aluminium. And compared to the Arlec units, they do draw more power at 10 watts versus 9. As a result, it puts out around about another 100 lumens, totaling 940. The other stats are pretty consistent with the Arlec unit, with a color rendering index above 80. The color temperature is adjustable through the app between 3000 and 5700K, so a nice cool, almost blue light, through to a warm amber glow. And again, like the Arlec units, I got the RGB lights because, well, why not? So now to get to the hacking. Now I've discovered that while the Arlec Grid Connect downlights are flashable if I dig them out of the ceiling, open the control box and solder a header to the control board, then plug them into a serial cable, these units allegedly should be flashable in the same way as the Genio smart bulb. And if you haven't checked out the video where I hacked that Mirabella Genio smart bulb and installed Tasmota on it, then do check that out, as there are some prerequisites for over-the-air flashing, and I cover setting those up in that Mirabella Genio video. To reiterate, we need a Linux computer with a Wi-Fi card that can be an access point, and again I'll be using my Raspberry Pi 3B+, and we need a donor device to connect to the Wi-Fi created by the Pi to keep the connection alive, and for that I'll be using the Node MCU here that's already conveniently flashed with TUYA Convert donor. Our Linux machine needs to have TUYA Convert installed, and I did cover that in the Mirabella video as well. So with our prerequisites out of the way and the light out of the box, let's install it in my set wall here and try and flash it with Tasmota. Now these lights are pretty easy to install. and I've got my set wall up here so that you can see how to go about it. Now on the back of this set wall, we have a plug base, which is hooked up to this light switch, and we've got the correct size 92mm hole cut in here for these downlights to be installed through. So I pass the cable up through here, pass the control box up through, and we need to push these springs back and feed those springs up through the hole. And then once we're past a certain point, those springs will splay out and hold the light up. And it's important to make sure that you don't get the cord caught by one of those springs. And then I'm going to have the control box sitting on this top plate here, and just behind the wall, I'm plugging this GPO plug into the plug base. And that's installed. So now if I turn it on, we see that the light is on, and it's on at 100%, and that's quite bright. So to get started with flashing, I'm going to SSH into the Raspberry Pi. So SSH Pi at 192.168.1.155, and the password is Raspberry, and we are signed in here. We're going to CD to OTA convert, and to make sure that I've got the latest version of OTA convert, I'm going to run git pull, and that's going to check that we're up to date, and it was already up to date, so we are good to go. I'm going to quickly list the contents of this folder just to make sure that I know what I'm doing, and I'm going to run /start flash. And yes, I want to terminate DNS mask. Yes, I want to terminate mosquito. It's now starting the access point. Okay, so I have a computer connected to the vTrust Flash Wi-Fi network, and we need to put the device into auto config or smart config pairing mode. So to do that, we need to turn the light off, on, off, on, off, on, off, on, off, on, and we should now get it flashing. That may not have been enough power cycles, so 1, 2, 3, 4, 5, and let's go 6 for good measure. Okay, fantastic. We've got it blinking in config mode. So let's press enter and see what happens. So it looks like that's connected. Smart config complete auto retry. Resending smart config packets. Smart config complete auto retry. Okay, I've read about this issue. So it looks like this particular light has an updated version of the OTA firmware on it and won't be able to be flashed over the air. So I'm going to have to pull open that control box in order to flash this light. So we will cancel this. We'll exit SSH, and I'm going to turn the light off. We're going to pop out to the workshop in the garage, and we're going to crack open the control box on here and see if we can find the points that we need to flash this light. Okay, so we're out here in the garage, and I'm going to start by undoing the screws here. And a little trick I learnt working in computer service is getting an ice cube tray to keep the screws in. So I'm just going to pop those in there so I don't lose them. Okay, and I'll just pop those in there as well. Now obviously I don't have this plugged into power because that would be stupid, because we've got live and neutral right there, and we don't want to electrocute ourselves. What I might do is grab a metal spudger and get that in there. There we go. Perfect. So we've got the back plate off, and we've got the board here, and if we flip it over, we have our ESP module is this little white unit here. Okay. Now this one might be a little bit difficult to work with because we've got these tiny copper points on the back of the board, and I can get it to focus. So we've got the TX and RX pins there, we've got a ground pin there, and if I can read those, 3v3 ground, IO0, IO2, RST 4, 5, I3, I2 and I4 I think. So what I need specifically is I need the TX, the RX, the ground and the 3v3, and I will also need to touch IO pin 0 with the ground pin in order to make that go into flashing mode. So what I'm going to do is try and solder some leads to that, and we will take it from there. Okay, so I've got these leads that I prepared earlier with these DuPont connectors, and most of them just have bare ends, and I'm going to solder these to the ends. Now I've pre-tinned the test points on the back of the board in here, so I'm going to start with ground, a dab of solder. I've just got a little USB fan over here just blowing the solder smoke and gases away from my face, and I'm shaking like crazy before. So that's the ground on, and need to get TX and RX, so I'm going to go with orange for RX. Excellent. Green for TX. Great. Now I'm just tacking these on because they don't need to be permanent. I will be removing these. And on the back here, I'm going to tack this red wire onto 3v3. Okay, perfect. So I've got my black is ground, my green is TX, my orange is RX, and my red is 3v3. I have an extra black lead here because what I need to do with this is connect this to the GPIO 0 pin when I'm booting it up, connected to my USB to TTL converter. And that will put the ESP8266 in here into flashing mode. So now I need this red to go onto 3v3 and VCC on my USB dongle. The black is going to ground. TX on this control board, or transmit, goes to RX or receive on the light controller. RX on this board goes to TX on the light controller. Now the last thing that I have to do is hold this ground pin onto GPIO 0 as I plug this USB controller into my computer. So I'm going to sign into my computer over here. Okay, so I'm going to start up Tasmotizer.py and that should come up. Alright, and I want to very delicately hold this ground pin onto GPIO 0 while at the same time plugging in the USB key to my computer. Okay. Hopefully that was long enough. I'm going to refresh the devices and we've got TTY USB serial. I'm going to back up the original firmware. I'm going to change this select image to release 920. So we're going to install Tasmota 920. We don't have a self-resetting device and we are going to erase before flashing now. So pretty much I've already voided the warranty, so let's click Tasmotize and see what happens. So it's downloading. So it's failed to connect. It may be that I wasn't on that GPIO pin properly. So let's unplug, get onto that GPIO pin and plug in. So it did connect and it's telling me that it's an ESP8285 rather than the ESP8266. So we're just waiting for this to back up, then it will erase and then it will write the 9.2.0 version of Tasmota to the flash on the ESP8285. So it's asked us to power cycle the device, wait a moment and click OK. I have already power cycled the device and I've waited a couple of moments and I'm going to hit OK. So it's already backed up the device, it's now reconnecting. And it may actually fail because I didn't have the GPIO pin connected. Yeah, so it's failed because I didn't have that GPIO connected. So I'm going to redo this. This time I'm going to uncheck save original firmware. So because we've already got a backup of that firmware, we should be okay. So I'm going to Tasmotize. Okay, good, so it's uploading and it is hard resetting and it's telling me to power cycle the device. So I'm going to power cycle the device and we'll see that we have Tasmota here. So if I connect to that Wi-Fi network, we should then, so we've got our captive portal and we can scan for Wi-Fi networks and we want to connect to the Force and I'm going to type in the password and I'm just going to tick this box to check that I've typed the password correctly, which I have. I'll leave the host name as is The AP2 will leave all as is, and we will click save. The device is going to restart itself and join our force Wi-Fi, and we should then be able to find the device. Let's go LAN scan. And go to scan the network, and we're looking for, this one looks familiar, so 192.168.1.229, so let's connect to that. So there we have the Deta Grid Connect control box on Tasmota. Now I'm going to need to grab the details for this particular unit and do the configuration, but what I'll do first is I will disconnect these leads, button it back up, and then we'll head back inside, plug it into the set wall, and then we'll check it all out. So okay, so we're back inside. We have reinstalled the downlight into our set wall, and if I turn it on, it has turned on and it's flashing blue while it connects to the Wi-Fi. So let's go to the IP address of the downlight, which was 192.168.1.229, and we should hit the Tasmota page. Now we need to obviously configure this, so we're going to go to Blackadder Tasmota. So we'll go to templates.blackadder.com, and I want to go to search, and on the box here I'm going to look for the model number, which is DET902HA, and I'm going to search for DET902HA. So we've got Deta 10 watt RGB CCT downlight. And so now that we have picked that up, we should be able to just grab this template. So we'll pop back over to the Tasmota screen for the downlight. We'll go to configuration, and we're going to go to configure other, and inside the template I'm going to paste in that template that we copied from here. I'm going to tick the box activate. I'm going to give the device a name of Kitchen 1, a friendly name, Kitchen 1, and if we wanted to, we could add some emulation here for either Belkin Wemo or a Hue Bridge. I'm not going to worry about that now, but I am going to click on save, and we've just seen the blue light has turned off and the light is restarting. Okay, so the light has come back up, and we should now be able to click toggle and the lights come on. If I move this slider up, we have a slightly greenish tinted light. We can change it to warm white, back down to cool white. We can go to different colors and move this slider across. So we've got blue, red, green, and we've got brightness control here as well. Pull that saturation back down, so we go back to white, and I might go to that kind of middle of the road there. I'll bring that brightness down to halfway as well. So we've got the configuration for the light set up. We now need to make sure that we've got the configuration for MQTT set up. So we'll go to configuration, configure MQTT. So we'll enter the host name, which is 192.168.1.20, and I'll just click save, and we will see if that fixes anything. So it's just restarting the device. I'm going to open MQTT Explorer, and I'm going to sign in to my Mosquito server. So connect, and we see we've got Tasmota, we've got telemetry, and we've got discovery. So we've got that device there. So now if we pop back over to Home Assistant and we go to configuration, integrations, click add integration, and we'll type in Tasmota, and we'll add that integration and leave the topic to Tasmota/discovery. We'll click submit, and we've already found Kitchen 1 and we can select the area, and I'm going to put it in the kitchen, and we'll click finish. So we'll pop back over to the overview and we will scroll down to the kitchen, and we've got light number 1, so we can turn the light off and on. If we drill in to the icon there, we can change our white value, we can change the color temperature between cool and warm white, and we can change the RGB color as well. And similar to the Mirabella Genio, we've got some different effects in here as well. So cycle up, it cycles through some colors, cycle down, cycles through some colors. Okay, so that is the Deta 10 watt CCT LED RGB downlight with Grid Connect, hacked to remove the Grid Connect and install Tasmota. I do really like these downlights, and I think I'll be digging the Arlec downlights out of the ceiling here in the dining room to flash those and get them into Home Assistant as well. Cracking open the control box is obviously a risk. All of the warranties are now null and void. We've put our custom firmware on there, and we do also need to be very, very, very careful because we are dealing with stuff that is connecting to mains power. And that can be quite dangerous. This light is super bright at full tilt on cool white, and it's going to be absolutely awesome in the kitchen for when we're cooking, and the RGB function is going to be absolutely fantastic when we're entertaining, especially with some of those color cycling effects. The fact I now have full control over these from Home Assistant is going to be a massive win for me here. So if I do end up replacing more downlights, I'll definitely be sure to flash them with Tasmota, and I'll hopefully be able to do them over the air instead of having to go and pull apart that control box. But now I know what I'm doing, I should be able to do that without too much hassle. I do hope that this video has helped you in your smart home journey. I know I had a lot of fun with hacking this, and it was a lot simpler than I thought it would be. If you liked this video, drop a thumbs up, share it with your friends and family, and if you want to see more content like this, please consider subscribing to the channel and hit that bell icon to get a notification when new videos are released. Lastly, if you like what I'm doing here and you want to help support the channel, I'm not currently sponsored, so if you hit the Buy Me a Coffee link in the video description below, your contribution goes towards making more and better content for you to enjoy. That's all we have for this video. I'm Stu from Hive Mind Automation, and I look forward to seeing you next time. Bye for now.